yet. Now it's going live. Okay, so it seems we're live. Maybe somebody could type something into the chat to confirm that the stream is working okay for you guys. I can see my stream helper Eric typing the hello, but does can some viewer type something there, if possible, to confirm that you can also see the stream? Well, I guess we'll just assume that it's working because I can see the video working. Great, great. I take that as a confirmation that it does work. Okay, so here I'm gonna show a few cases live. They're a bit adapted from the requests that I got in society. I'm just gonna start from the real beginning, so I'm gonna skip a few steps, but I'm gonna show what I have done. So I'm not gonna make you watch how I install Java and so on. But so what I have pre-installed, I have Java. So I'm using Adopt OpenJDK, and it's version 15, but you can use anything. You can use 11 or anything newer. And then on top of that, I have Maven installed. Basically any version of Maven. Maven should work, it doesn't matter. Then I have my Solibri installation. I have installed the newest version, 9.12.6. Using an older one is fine, but not everything works in the older versions, so some API additions are in the newer ones only. And then I have installed Eclipse. So you can use any IDE you want, but I installed Eclipse, and the one you want is Eclipse IDE for Java developers. You can use IntelliJ IDE if you want, or any other. So I have those installed ready. And then once we get started, the easiest way to start developing your own stuff is to go to our GitHub, the public GitHub API examples, and download the code package. Now I have already downloaded it here, and I have the whole bunch ready here. And just so that we can confirm that everything works, we can on Windows run the build all command. So what the build all command does is it just builds every subfolder here separately. We can see it working, and what it does, it builds them, and it actually let's see if I can get the Lindqvist working. It actually copies all the files to my installation automatically. So I have them here. You can see the timestamps update. So those should be ready now, I guess. And let's just save this that I had open. Let's restart Solibri to make sure that we can see these API additions. They should automatically be available. Just a second here. And the easiest way to see it is to check what kind of views we have available. We have these example views, so you can see that the API additions are there. So I wanted to start with something simple, and in the society forums there was this request about using, like, combining existing ITO columns and doing something like like combining them, multiplying things or others. So I'm gonna implement this quite simple custom information first, and it's about combining a classification result for a component and then using that as a cost calculator. And what we're gonna do is we're gonna take walls, for example, and we're gonna take the volume of a wall, and we're gonna multiply the volume by whatever number the classification produces. So the classification here in this example is sort of what is the cost of the material for the wall. So by multiplying with the volume of the wall, we get an estimate on how much the material for the wall is gonna cost. And we're gonna give it a custom setting so the user can modify this classification name that they're gonna be using, just so that we can showcase how to use the custom settings. So let's get started by going into this template we have. So we have a template for information. So we can take this existing one and let's erase kind of everything that it has, so we can start from fresh. So what we're gonna be outputting is like a price, basically, and there is no separate type for price, so it's just a double, so it's a number, euros or dollars or whatever. And let's give our information name. So let's name it something like cost of wall materials, and let's also name our class based on that. So wall material cost information. So we will now easily see in the application if it's present or not. And now we don't really have it do anything yet, but let's make it just do nothing. And then let's go into the folder SMC API info template. Am I in the right place? The info template, yeah. And let's build it. Let's just check that it builds. So we can see that it builds and it copies the package to the installation. So we can see it here. And now let's, just to make it clear, let's delete all the others. So we probably have to close this because it's using those. And then let's delete them. And one thing I forgot to do here is we will have to change, or we will have to update this also here. And let's rebuild it. So now let's see if we can find it from the software. Let's open some model. And now if we take an ITO we can check if we can find our custom information, and it's visible here. Now we can already do a takeoff, but it produces empty for everything since we didn't make it do anything yet. But it works, it can be found. Now I have prepared a little classification in this file. So this is just an example that I defined for walls. So it's defined for any wall, and based on the type information from the wall, so type here, it classifies them as having some sort of a price for the material. And so we get a classification where all the walls get some kind of a pricing. So we can then try to use this information here to calculate the total cost. So what we want to have is total cost equals volume times cost factor from the classification. So let's first try to find out the volume. So getting these volumes and areas and lengths and stuff, we can use this quantities interface. So we basically ask quantities for this component, and from those quantities we get the volume quantity, and what we get as output from here is a double, and it's an optional double. So not every component has every kind of quantity, so they might not have it defined. But we are doing this for walls now, so let's also start by rejecting everything that isn't a wall. So let's see if we have this available. Yeah. So if it's a wall, we want to work with it, but if it is not a wall, we want to return empty. So this cost is not defined for anything other than walls. So here we can also now do like this. So whatever we have here, they are always walls. Yeah. And to make matters simple, let's just always assume that the volume exists. You might want to have some kind of error handling here, but let's just assume that every wall has a volume. So now we have the volume part of it known here. And then the other part was reading this classification. And let's check how we can read classifications. And here I'm gonna use as an example the API documentation that is online, and we can see this classification package here. So there's some methods related to getting classification results. So there's this classify method, which actually recalculates the classification for any component you give it. And let's try using that. It's found under here, which might not be apparent at first, but, and we need to give it a classification name. So what have we named it here? It's cost per cubic meter. This should find that classification object, and it's optional because you might not find it for a given name. But here let's also assume that we have gotten the right name and that it always exists when we run this information. And now let's classify the wall, and when you classify things, you might get multiple results. And here, let's just assume that there's always a result, and let's get the first one to keep this example simple. And let's get the name of it. So, result name. Now we do have the cost factor, since it is this name, but we have it as a string. So let's convert it to a double. All of these in this example are integers, but it doesn't matter. Cost factor. Let's parse it from that. And this can also throw exceptions if it's not a number. And now we have the volume and we have the cost factor, so we should be able to just multiply them and return that as the value. Now we can try building it, and let's close this, rebuild it and reopen it to see if it actually works or if we have made a programming mistake. Let's open the model with the classification, otherwise it can't calculate anything for you. And let's find a wall from the model. We do have the custom information tab here visible, and we seem to have a number here, and that's a good sign. So let's just confirm that this number makes sense. We do have it for a lot of walls here, and for wall 0.3 it's 496, and it's calculated from the volume, which is 1 point something in cubic meters, and let's see what type it is. It's IW 100. Let's see what we put it for that. 400 per cubic meter. So we have 400 times 1.24, and it comes to this amount. It sounds sensible. So here we have information that tells how much the materials for this wall are gonna cost based on this classification. And we now showed it in the info viewer, but we can also use it elsewhere. For example, let's not do it here, but let's see how it behaves in ITOs. So I have something pre-made here, so I wanna do an ITO for all the walls, one component per row, and let's change this to be cost of the wall materials, and now I get the cost of each and every wall here, and this can be then exported into Excel or wherever we like. So you can use Solibri as a tool to calculate some costs here. And these were used like now it was used for like outputting data. And the nice thing about these custom informations is that you can also use it in filtering. So I can use it as a property here, and I can say that okay, I wanna output only expensive walls, so only the walls that are gonna cost a lot. so those that are gonna cost more than 1,000 money units, and now it only outputs those. So I can use it here, and I have some rules here, and it's possible for me to also do it so that, okay, I want to exclude anything that costs less than, let's say, 200, or I want to check anything that costs more. So making this simple custom information allows all kinds of usages, not just for outputting data or viewing it. And I promised that I would also show how to use the settings, and let's do that as well. So let's check if we have some good setting examples here. So I think in the view examples we should have some. Let's check if it defines. It does define some settings here. So we have this a simple well, this is password setting, but okay, we have checkbox boolean setting and integer setting. Let's copy paste this file here. So let's make it a simple string like this, and let's rename it wall material cost classification name setting. That's a long name but descriptive, and name of the cost factor classification, and default value, let's take the default value from here that we used previously. Now, similarly to the information, we do need to copy this services file for it, and I have it here, and let's put it like this. So it tells Solibri that when to look for settings, look for these implementations. And we could also define these groups and dialogues for it. Let's do that so we can show all of it. We will get nice setting menus there. So group, let's define this setting group that it only contains our new classification name setting, and let's do it like this, something like this. Let's rename it as well. Cost factor. And so this group is used for grouping inside a setting pop-up. But let's make it also have its own pop-up. So let's rename this. Let's call it cost analysis, in case we do extend this cost analysis thing with a lot of settings. So they will be in their own dialog, separated from the others. Cost analysis and cost analysis. Now we could also translate these by creating these kind of property files, but I'm gonna skip that step for now, since it's quite simple to do the translations. So okay, now we have created these settings things. We also want to use the setting here. So now we are using this hard-coded name, but let's make it use the setting. So smc get settings and get setting, and here we will ask for wall material setting, and we can define it here. I guess we can do it like this. And then here, let's ask for the value. And now we should be getting the classification name from that setting we defined. And it's built. And let's restart again. Okay, so we got an error. Cost analysis setting dialog not found. So we did get this here, and it tells Solibri to look for this. But the problem is that it's looking for this package name, and we forgot to change the package name to the correct one. These all live inside a different package name. So let's fix this for all of these. This is an easy mistake to make, to forget either adding these or then adding new lines to it. Let's rebuild it. It should all have the updated package name here. And let's restart and see if it's been fixed. And now let's go and see if we can find our setting. Okay, so we have our cost analysis here, and it has one setting. We could give it an icon. The setting dialog should be able to make you give it an icon, so we could define an icon. We don't have to implement the get icon method if we just put the image file here into the resources folder with the correct naming. But I don't have an image file now with me, so I'm gonna skip it. But as we can see, the icon is not needed for it to work, so we have it here. So let's see if it still works. And let's navigate to some wall here. And custom info. So we still are getting nice values here. Now let's change the setting. So let's make it look for something else, like cost per cubic meter too. So we've inputted a wrong value now. And as you can see, the tab disappears. And why does it disappear? Let's check from the logs. So we have our logs here. Let's reload it. And yeah, so we are getting exceptions here. We have a programming mistake. So on line 32, So we are getting the value out from the setting, and we are trying to find a classification with that name, and then we just assumed that such a classification exists, and now the assumption doesn't work anymore. So we could fix it by making an if statement here and outputting some logs, or yeah, but I'm gonna skip that part. We just adding some Java code here, but we can now fix it by changing it back, and it appears again. So we are getting numbers here again. So that was kind of the first example, the simple custom information example. So does anybody have questions about this specific example? We can possibly extend this if somebody wants to see something related to it now. So type into the chat if you want to see more about this specific one. One possibility here is that how these classifications are defined. So now we define them in Solibri, but these numbers could just as well come from somewhere else. So they could come from an external file. So let's see if I have a good example here. I think I put it here. So they could come from an Excel file. The Excel file could contain, in one column it could contain the type, then in the other column it could contain the cost factor. And we could read them live from the Excel file instead of keeping all the data inside the SMC model. That way you could have multiple projects reference the same cost Excel. You wouldn't have to copy the classifications from one project to another, and you could keep them in an external file. And maybe it would be easier to update them if it's in an Excel file. I think we do have some examples here that handle Excels. So we have an example that lets you point to an Excel file, and we have an example that reads the given Excel. So what it does, it uses this POI library, which is a free library for reading the Excel workbook, and it finds some information for a given component from that. So maybe I'll skip that part here, but combining this found from Excel example and what we did here for the cost analysis, it's quite simple to, instead of the classification, get the cost factor from an Excel. It's you just read the rows and the cells and get the information out of that. And let's see, if you wanted somebody to be able to use this custom info that you have done, all it requires is you to take this jar file and give it to your friend, and they need to have it inside their installation. But in the recent versions it's also been possible now to package them inside these company extensions, so it's actually possible for you to add the jar here. So I could go and look it up from my Solibri installation folder now, from the library, and where do I have it? here. I could take it from here and I could package it, and it would be available as an extension, and you could download it from here. So it makes the sharing a bit easier, and everybody ends up with the same version, and you don't have random files being copied over. Okay, we can move on to the next example I had in mind. It's based on the idea. It's based on the idea from society about the ITO calculations for spaces. So let's check what I wrote for it. So the idea is, let's just show it in Solibri. So I have spaces here, and I want to calculate something for the spaces. And as you saw, you can use the custom information here. This is not defined for spaces, but we can still try to use it. But the problem with the ITO here is that it's quite difficult for one component to produce multiple rows. So it's quite easy to group components, so that for multiple components you produce a single row for results. But it's a bit difficult to make it so that for a single component you get multiple rows. So if we want to have something like what we have here in space boundaries, where for a single space we get multiple rows of information, the ITO might not be the best solution for that. So let's try and see if we can build our own custom view that displays what we want for the spaces. Okay, so let's start with like an empty view. Let's take the view template here. Example view. Let's close everything else, and let's name it something like what could it be? Space information view. And let's have the name that as well. So now it's an empty one. Let's give it a label, space information, and let's update naming here. This also has an example layout. Let's delete it so that it's or let's not delete it actually. The layout maybe allows us to show a case where we define our new view to be part of some default layout, but let's leave that for later. So now we have space information view, and we should be able to compile it. Let's see, view template, and let's package it. Let's close this one. And it's built, and let's check that it appears here. Yes. Okay, so let's see if we can find our new view, space information. All it has is one label that says space information, so there's no content yet. No. So let's start building the content. So we want something like a table, and so we're using Swing to build this. So let's check some simple Swing table example, and here we kind of see it. We need to give it some column names and we need to give it some data. So let's copy paste this example and let's define our table. And let's add the table to our panel. So add, and let's add this. Let's call it something else. Our table. Much better name. So now we should have some sort of table embedded in it. So let's just rebuild and restart and see if we get some kind of a table there. I'll try not to focus on how ugly the UI looks. It's probably gonna look a bit ugly since we're not doing any styling for it, but okay, here we can see that we do get a simple table here. So it already works for outputting data, but let's try to output real data there. So what we wanted was we wanted to show some information about spaces, and how do we pick which spaces to show there? Let's see. So one possibility is that we use selection basket for it. So we could show information about those spaces that are currently in the selection basket. So let's check if we are able to get spaces inside selection basket here. See, get selection basket, get a set of components, and let's also only take, no, I need to stream it first, and let's only take those components that are spaces. So component is an instance of space, and let's collect those to a set. So now we have a set of spaces in the selection basket. We also do need to map them like this. Cast them to a space. Let's see if this works. Like this. So now we have spaces to work with. Let's refactor this into a method. So it's a bit simpler to use. Get selected spaces. And we wanna make it so that we can actually put it here into this table. So what are we gonna put there? Let's put a name of the space, and then let's start with just the name of the space and some information about space. So we can, let's like put the amount of doors in a space. Amount of doors. So it has two columns, name of the space and the amount of doors in it. So now this is gonna be empty now, and we wanna somehow put the spaces there. Now this JTable takes as input these arrays, but it's also possible to give it these vectors, and vectors are kind of old lists, so column names and the data. But okay, we have the column names here, and we have the data here. So let's maybe turn this into a vector. It's a bit easier to work with than the array, because you can more easily add things into it. So this is a vector. It's now empty. So this is a vector of a vector. So it's a two-dimensional list. So a table. And let's also turn this into a vector. They both need to be the same type. So new vector from these. Now the data is now empty, but let's try to add some things now into the data to see if we can get it there. Let's add a new vector. So this would be like row 1, and it would have the name and the amount of doors. So name and amount. And how to get those? Let's first get these. And let's do a for loop here. So for every space we want to add one row to the table. Get selected spaces, and let's put this inside the loop. And for the name, let's put name. And for the amount, let's put what was it called? Doors, and let's take the size of the door list. And now it complains because this is not a string, but this is. So let's turn this also into a string, and it hopefully works like this. Let's see if we got it working. Let's restart it. And we want to have a model open. So let's open a model that has some spaces. Now you can see that the table is empty. We don't have anything in the selection basket now. Selection basket is empty. Let's say we find a space from here, and we add it to the selection basket, and we have something else. So we have two spaces here. But this doesn't update. And it doesn't update because when we first initialized the panel, we already filled it from the selection basket, and at that point the selection basket was empty. So we want to make it so that it updates on the fly, and we have this convenient method here on basket selection changed. So let's implement this. So our view will react to Solibri changing the content. So what was it? This was the old content and new content from the basket. New is not allowed. New components and old components. And let's also check from the API docs. Where was it? The view. So the view is in SMC API UI view. Here. So it has method on basket selection changed. Old selection, new selection. And yeah, it takes those as arguments. Let's see what's wrong with it. And it needs to override. And it complains about something else. Did I write it wrong here? Yeah. Just needed the import. So now we can update it when the selection changes. So we do it at the initialization, and we can also just copy paste this here and try to do it here. But okay, the data is not visible for this method. So let's move the data to this scope, so it lives not inside this initialization method, but it lives inside the view itself. So let's make it private to the view, and now we can add to the data here as well. Now you can let's remove this, empty it. Now you can see that okay, we access it here, and we put it to the table. Now, whenever the basket selection changes, we add new rows. But let's make sure we don't have duplicates, so let's always clear it first. And let's see if this works as intended. And let's open a model so we can add something to the basket. Now it's empty because there's nothing there. And let's find some spaces. Add it there. And let's add another one. We now have 2 spaces here, but I guess something is wrong. Okay, we did get it, it just didn't update itself until I clicked it. So I think we do need to repaint it. So let's see if we want to repaint this table. Let's also put these here into the common scope that we can repaint the table whenever we want. Okay, let's remove this and let's remove this and so on. There we have this repaint call here. This should help with this problem. But okay, we can still try with this a bit. So now we have 3, and now when we click on here it updates. But hopefully soon it will update automatically. And let's remove something, and it does not update properly, but if we move it around it does. So at least the data handling works now, and we already have added this repaint call here, so it paints the table again when something updates. Now we could maybe make this table a little bit more complex. This might not be that useful yet. We are also missing the headers here, so they are not visible. Let's see if we can get them visible. Let's maybe give it some bounds. Maybe that's the problem. This is a bit of UI work. Let's try not to do too much of it. Let's just set some bounds here, and yeah. This should hopefully make the headers visible for us here. But yeah, let's try to make this a bit more useful, this table. So what I had in the example was that we would be able to provide multiple rows for one component. So we could add one row for doors, windows and walls for each space. So the most easy way to do it is like this. Let's get windows here and add the size of the windows, and let's see if we have walls. Do we have? And let's check the space interface. We have doors, openings, windows. Immediately, easily. Let's go with the easy ones here. So this should produce now 3 rows per chosen space. And let's make it a bit more easier to read. So type of related component. So this will tell if it's talking about doors or windows, the row. And so let's add it also here. So here we would write this is doors, this is windows, and this is openings. And let's try to see if that works as we would like it to. And it's already built. We do have to restart the application a lot, but building these simple things doesn't take too much time, so it's quite fast anyway. And let's now add some spaces to the selection basket. And now we can see that it updated immediately. We do have some sort of problem here. We only see one column, so let's see if we made a mistake here. I think here we did make a mistake. We forgot to update this, and now this is a problem for us. We have like 2 places where we run the same code. So let's refactor this into a separate method called update data. Let's also put this clear call inside it, so it will automatically update in both places. Let's check if we got some errors in the logs from this case. No. Well, yeah, okay. We have 3 columns here. So we have the name, then the type, and then size, and we have the column names defined here now. Let's check if this fixed the issue of only showing a single column. Let's reopen it. Okay, so let's see. We have a YouTube comment here. Is it possible to get information from custom view table to Excel? This is a great question. A good question. So we now have added this table here, and let's see if we can get it visible now. And we would like to be able to export it into Excel at some point. Okay, we still have this. I need to likely debug this, but we would like this into Excel or some other format. We would like to export it, and it is possible. We do have one exporting example here already. It doesn't export to Excel, but we have an exporter for checking results. Let's check it fast. And in that case, we define a button that starts the export. We define a target file, or actually we don't have a setting for it, but we have a button that exports, and then it runs this exporting code. So here in our case, we would, in that exporting case, we would write an Excel file using Java library for writing Excel files. So yes, it's possible, and I think we might even have time to implement it here as an example. Let's see if we do. Okay, but we had a small bug here, so we can see that okay, it does add 3 rows per component, so that works fine, but it doesn't show all the columns. So I guess that was just a rendering thing. We might need to work on the UI there, maybe something to do with the sizing or something, but okay, when we made it bigger it appeared. But okay, so the basic functionality is there. We have space, and we can print multiple rows of information for it, and it seems to work nicely if you don't count that rendering issue. So let's actually try to export it into Excel. So a simple Google search, Java write Excel file, and this should give us the Apache Poi project as an example. Let's take this. This usually has good examples. So it tells you to put these Maven dependencies, and here in this view template, let's check what dependencies we have defined already. So this is the default one. It includes the Solibri API, so the geometry API and the general API, and then it adds this logging framework, so we can log the normal Solibri log file, but it doesn't contain the Excel library. So let's try just copying these. Actually, okay, yeah, let's just copy them here. So now they are there, but let's try to find a bit more newer version. So we can go to this Maven repository, and let's search for this library here. So Poi OOXML, and it would show us what are the new versions. So let's try to use as new version as possible. Let's not take the 5. Ideally we would take the 5, but I know for a fact that Solibri uses version 4 currently, so let's use also the version 4 so we don't get any annoying clashes. So 4.1.2, and let's hope that it's the same for this other as well. I think it should be. Let's try building it. It should work. Let's check if the libraries are included here now. Okay, we have the classes here, and so it does not bring the libraries that we would want with us. So we can check from the Maven build file that it compiles everything, and then it makes the jar file. And in these templates, it's not included the bundling of your own dependencies. But in these examples, we do have some usage of external libraries, and we have this plugin that bundles them into the jar, and that is mandatory. Otherwise, when you run it in Solibri, Solibri can't find the dependencies unless you happen to be using dependencies that Solibri already has. So we can use this shade plugin and the point of that is that it takes all the external dependencies also and it bundles them into your jar. So here you can see that it includes all the Excel writing libraries, and we can also check that, okay, now this size is much bigger, so it probably includes a lot of stuff, and yeah, so it includes these Apache libraries for writing Excel files. Now in order to write the actual Excel file, we have this nice table here, so I think this translates into Excel quite nicely. We just make a cell by cell transformation, and this example is for reading from Excel, but now we want to write one. So there's this, we create a workbook, we create a sheet, some headers and header cells, and then we write some cells, and then we output that to a file. This example was made with version 3. Let's see if we can find an example with the 4. So it would work automatically. Okay, let's start from this example. They probably both work with minor modifications, but let's just start by copy pasting. Or actually, let's make a button first. So we need a button that exports, and let's copy the button from this other example. So let's define a button, put it here, and we need to initialize it, and let's copy that code also from here. Here, so we just create a simple button that export to Excel and export data. And let's create this method. So currently it doesn't export anything, but you can press the button. Let's try to get it working as much as we can before we test it. So let's copy this stuff. And we need to import a few lines here from the Excel library, and let's space data, let's call the sheet like that. And here we have the example data, but we don't want the example data. We don't want to use that. We could use it here, but let's already try to use our real data. So let's put this away. Let's format it. And now this is empty. We need to get the data from somewhere. Luckily, we already have access to the data, so let's just use this. But it is not an array of objects, so let's change the type. It's a list of strings. And this one needs to throw an exception. Where do we use this workbook? Resource leak. Okay. Let's also fix that while we're at it. So we wanna always make sure we close all these resources in Java. Usually it doesn't matter, but in the worst case it means that you can't modify. Let me just close this before these guys end up in the street. We will choose a file name for this, and it will write the object there. So book, let's rename this variable. So this is a data row for us. It should be one row from the table. It should be of this type. this is already a string. So this is one field from the table, and it should be always string. We know it is a string, so we can simplify this. So what we have is for every row in our data table, we create an Excel row, and for every field we create a cell, and then into the cell we put the value that we had. And it all happens when you press export, and this throws some warnings in case you aren't able to write the data to a file. Let's just print the stack trace for now. We can add the proper login, but let's try with this. And let's close this, rebuild, and see if it actually works. Let's open the model. We already have a huge button here, so as you can see, it's a really big button, and that's because we didn't do any kind of UI styling for it. But let's see if adding some spaces to the selection basket helps with the case. So, okay, the button is still quite big. I think we do need to do some UI styling here to make it a bit nicer. In Swing, the easiest way is to use this grid bag constraints. We don't want anything too difficult. Let's just copy some. Okay, do we have an example here? In this example, you create these labels and stuff, and you have this layout. Let's create this layout for our components. So in here we have three components. We have this one text field label, we have the table, and we have the button. So let's try to make them act a bit nicer, and let's set the layout for our panel. So for this panel, this is the root panel that our view has. So now it should be using this grid bags, which is kind of well, it allows us to just align things nicely. And let's create these constraints. Let's just copy paste this from here. Like this. Let's see if we can get it to be a bit nicer. So it should divide these components horizontally. And now it's in the example it's adding these buttons there, but let's add our own things instead. So let's add this label to our panel, but let's add it with these constraints. And the same thing for the table. Let's add the table, but let's use the constraints. And the last, let's add the export button, but let's add it like this. Let's see if it's a bit nicer now. Let's rebuild it. We're not trying to build too modern of a UI, just something that looks usable here in this example. Can be fine-tuned afterwards. Okay, so it's a bit nicer, I would say. Of course, here you don't see the table is empty, but let's see if it adjusts to the table changing sizes. We could reserve space for the table, and we could align the button a bit nicer. Okay, so now we at least see all the components. We can make it a bit nicer. Now the table is in the middle, but probably we want the table to be at the bottom and for the button to be at the top. Okay, so now we do have the table and we do have the export button, and we can press it. Now I don't know if it works because it doesn't say anything. We can check that it does not cause any errors, and what we had it do is we had it write this file. Now this is a relative file name, so it depends on where this code is executing, where it's writing the file. So it might end up here somewhere inside the Solibri installation. It might end up, it depends a little on how you're executing and with what operating system and so on. So let's try to give it some sensible location. So let's go to my user folder and use that as the location. So it should be on my home drive. And at the same time, we want to make sure that we are not like silently failing here when we press the button. So let's try to add a proper logging facility here. So let's see. Let's add a logger here, and that's from logger factory, and we can give it this class name. Yeah, so this should now be able to log things, and let's make it log starting Excel export, and let's make it say that it's done. And then for the error case, let's make it say that it failed and give it the exception as parameter. And let's make this an error log, so it will here show if it's an info or something else. Let's rebuild and see if we can get our Excel file out of this. Start it, and if it works, great. But if it doesn't work, we might have somewhat of a difficult bug there if we don't get anything sensible out of the logs, and we might have to debug. So I might get to show you how to debug the code. But okay, now the table is a bit nicer. We have the button here on top of it, so the data will appear at the bottom. Let's add the spaces. And let's try to export. Okay, so in the UI we don't see anything, but let's go check the logs if there's something in the logs. It says starting Excel export and Excel export done, and it should appear on my here. I don't actually have Excel here available, but I just have to, I guess, trust that it's an Excel file. And why wouldn't it be? I think it is. Let's see if I can open it in, I don't know if the Microsoft Edge knows how to open it. Maybe it does. Okay, that's a bit too difficult. I'm not gonna go there. But we did get Excel export working. You just have to trust me that it's a proper Excel file. Yeah. And of course here we chose to export it into an Excel, and we could also export it as any kind of file. So this was totally arbitrary, but it shows the power of the custom views, that you can write your own exports in any kind of format you want. And yeah, here of course we use a static file name. This is probably something that we would wanna put into the custom settings, and we might wanna customize it even further. We might wanna maybe we wanna make the user be able to choose what kind of format they use for export. So they might wanna choose Excel, they might wanna choose comma separated values, CSV files, and so on. But this already seems to be a working example. These were the two examples I had in mind, but I do have free time still, so maybe we could have a technical break here. And if you guys have an idea what you would want to see more, do you want to see me develop this into some direction now, type it into the chat, and we can continue for a while still, if you guys have something you want to still see. So I'll just take a few minutes of a break, and you guys can have a break as well. Maybe we'll put a timer there or something if we can when the stream continues. Okay, hey, the break is over, and while we were having the break, I managed to get the Excel file downloaded into this online Excel to just prove to you guys that it does work. So we were able to write the Excel file properly. I was able to upload it there, so it does seem to work. And in the chat we had a comment about further developing the table. So now the table is it's close to what was in the space boundaries, and we could work on it even more to make it closer to what we have here in the info tab. So what we actually have in the info tab is instead of component counts, we have sum of areas, and the sum of areas is calculated by component type around the space, and also the components are also divided based on the type that they have. So we can do some work to make it a little bit closer to what we achieved here in the space boundaries. So okay, let's first change the column names. I'm just gonna copy paste this and save it here, so we will also have this version here. But okay, so we wanna change the column names, and here we only have the table for a single space. So actually here we do need 4 columns instead of 3. So first is the name of the space. Let's name of space, and then component type is the second, and then third is the type, which is different from component type, and then we have the total area. And now we have 4 columns, so we do need changes here as well. The first one we can keep the same. The second one we need the component type. So we do need a bit of a change here. We could extract these into separate methods. So let's do it like this. Let's call it add door rows, and here add window rows and so on. And opening rows. Well, this doesn't show the openings, so we can let's remove it. Let's start with just door rows and window rows. Let's start with the windows. So we want to get the windows for a space, the windows that relate to a space, and so that they relate through space boundaries. So space has this get space boundaries method. We can actually see that okay, we have a really simple method for getting the windows. This gets the area of all windows. It does not get the area grouped by the type. So we want to just get all the space boundaries. And for all the space boundaries, we want to study what they have. So let's see. And each space boundary has an area. So using this, we can sum these up and get sums here. And it also has this type, but we should not get distracted by this type, because this type is not the type we are looking for there. It's the physical or virtual, so we can't use that. But the type we are looking at there is the type of this related building element. So let's try to collect all the windows into a map. So like this, a map of the type to a list of windows. So type to window map. There's a new hash map. Let's see if we have the window in the API, yeah. And we have map and hash map. Okay, so we want to collect these now into the maps, and we do it so that we get the space boundaries, and let's go through all the space boundaries space has. Let's call it SP space boundary, and let's get to related element. So if there is a related element, if it exists, and if that related element is a window, then we collect an instance of a window. In that case, we get the window related. Let's just call it a window. Let's get it like this, and let's get that type from that window. Get component, not the component type and not the IFC entity type. Let's check what this type actually is in the API. So let's go and check the docs. Component is, I think, here. And let's check what kind of what kind of getters it has. So this is first one. You would think it returns the component type, but the component type is an enum telling which kind of object it is. So this is not what we want to use here. Actually, we need to check if we have this information available in the API. I'm not sure we. The IFC edit type is another thing that we are not looking for. Let's check if it's in quantities or something. Not actually. No, I'm not 100% sure where it is in the API, but this is a good exercise for how to look at the docs. So here, let's find the quantities. I think it's maybe it's not here, but okay. Let's close those and see where it is here. Actually, let's find it from here because I used it. So it's in API model. A bit hard to find from this. I guess we would have had to search. Let's see if it works. Yeah, should have used this one. And here we have the quantities. And there's different kind of quantities found in this enum. I wonder if we are in a case where the type is not available actually in the API. I didn't get to check beforehand. Let's see, maybe it is not available. I can't really check it here properly. But okay, in case it's not available, we can try to use something else instead as a surrogate, and then later check if we get to use the type. Yeah, so let's see if component has something Is it the construction type? Well, let's try with the construction type. I'm not sure if it's sensible for this, but let's see. So let's get the construction type of the window, and either it's a string or it's an empty. And now, if the map, the type to window map, if it contains the type key, then let's add it to the list. Let's get the list from there and add the window. Otherwise, let's create an empty list, new array list, and put it to the map, and also then add the window. So now we will get the mapping from construction types to all the objects. And then let's remove this. Then after we've constructed the map, we need to iterate the map. So type the window map and entry set, let's iterate it, it's entry of this type. This is a nice way to iterate a map where you can use both the key and the value at the same time. And inside this loop we want to add a new row. And let's check what we had. We had component. Now here it's a window. So the second is a window. The third column would contain the type. So from entry we will get the key, which is the type. And we have multiple windows. So let's just do it like this. We get the windows from the entry, get value. We want to get the total area from these windows. And the area it talks about here is not necessarily the window area. It's the area of the space boundary object. But if we check what kind of methods this has, so there's no way to get the space boundary back. So we've kind of lost that information here. And if we check, for example, a window in the model, and we check the quantities, it has an area. It has a height and width, and we can use this area here now in our code. It should be similar to the space boundary area that you get from the space boundary object. So let's just calculate all of those. So let's stream these. Let's map window to quantities of that window and getting type area out of it. And now we collect them to a list. So this would return now doubles. So we map the windows to their areas, and we have a list of doubles, but we want to sum them. So we can use from the stream API. Let's see, collect sum. Let's see what we get. Reduce. So this should help us get. and we need to use double here as the type of that is a double. And these were optional doubles, so let's also map that binary. Let's see. Does this need to be 0.0 so it works? Yeah. And so this in the end returns area of Windows. And so we put it here as the area. And we could do this same for doors now. There's a bit of code copy pasting here now, but let's go with the ugly solution first, and we will see if it works. So door, and here as well. And we have a door here, and yeah. Let's leave those like that and see if we did actually get something working here. Let's check a little bit. So we have 4 columns here, and in here we add 1, 2, 3, 4 elements. So those match each other. So we should at least get something into the table. Let's see if we get the right answer. And let's try to choose a single space first, so it's easier to compare. We can compare it directly to the info viewer, so we can open it here, and okay, we don't see anything even though it's in the selection basket, so most likely we have a bug here, something's crashing. Okay, so Windows cannot be casted to a door, so we forgot to change something here in the door code. Here we have the check, so let's just recheck if we left any windows there. No. And let's try again. And it's ready. So the log files are your friend, and whenever something happens, it should, if there is an on-code error, something you don't handle in your own code, it should be still visible in the logs, as well as the code that runs your view should catch any errors from it and handle them with some grace. Okay, so now we did get something there. We do have Windows 16, Windows W114, so we have them here. And we do have 34.65. It's a bit different from this, and 17.14. So as we can see, it is different, and likely the difference is that we didn't use the real area here. So we used the area of the window. We didn't use the area of the space boundary. In the info viewer it gives you the space boundary area. We can change it to use it, so let's try and do that change. Let's keep the space boundary here. So instead of the window, we save the space boundary here. Type to boundary map. That way we still have the information about the space boundary. Space boundary, let's put the space boundary there instead of the window, like that. And now here we don't have a list of windows, we have a list of space boundaries like this, and SBS space boundaries. And now the space boundary has area, so we can call that directly. So instead of this complex thing, we can just use space boundary get area, and the same sum code here. And okay, let's try if that resolves the difference. Now we didn't change the code for doors yet, but we can do that when we try to refactor the code a little bit into to be a bit more beautiful and more reusable, so there's less copy paste. And let's get the space here. And now it looks better. So what we have here is 17.40 and 34.65. So it matches. Now we can see that in our custom table, it's not as nice. We have a lot of fractions there. So we wanna format the values in a bit nicer way. So we have this available in the API, so we can get the settings, get unit settings, and get formatters. Unfortunately, we are missing some of the formatters. We do have datetime formatting, we do have angle formatting, and percentage formatting. We don't have the choice of how many decimal points you want to see. So we can just here try and use 2 decimal points. So let's Google this because I can't remember it. Let's format decimal points in Java, and here we have decimal formatter. Like this. Let's use it here. So format the value area, and let's put the area here, and let's try to use it here. So here we define, okay, what settings do I have? Okay, I have decimal point as dot, and then probably comma as the 1000 separator, so it matches this. I can now use it here, and let's rebuild. And let's restart. Now we should get it in a nicer way. Okay, let's see. Doors. This doesn't have any windows. Let's choose another one. So space 0.4, and we get these nicely formatted values. And okay, so yeah, this matches that. And now we don't have these meters. We can add it to the end here, or we could add it to the formatter. I think we could add it to here as well. But okay, now we get it in square meters. Let's remove the other one from the selection basket, so we can check what are the differences now in our new table and the info viewer. So we'll do list windows here. We do list doors. Doors hasn't upgraded to the new code yet. We're missing slabs and walls at least. The space boundary itself shows just the space boundary itself. We can add that as a special case, but all the others should work with a similar code. So we can try to make this a general code. So let's put a class here and the component class. Let's see if we can make this into a general function, and then I'm supposed to write this. Class is assignable from. I need to always remember which way this goes. Determines if the class is. Yes, I think this way. No, I think it's the other way around. So let's check if this can be assigned from whatever we get here, and this should be a general usage code. So okay, we have window here. We don't actually have to cast it as a window, since it doesn't use any window specific code. So we can just call it component instead of window. And I don't think we have any window code here left, so this should all work for every class. This thing here we need to change. Let's just add it as a new parameter. It's easier that way. Let's put it here. There's some variables here still named with windows, but let's see if this works. Windows class, and then it should output window there. Window. And for doors and door, and let's rename this. And let's check what others we have. We have door, window, and then what else did we want? We wanted wall, door, window, slab. Let's add the wall as well. Let's see if we have the slab as well. We don't have the slab available, so we do need to make its own method for it. It should be added to the API hopefully soon. This is ugly copy paste for now, but we'll remove these. Add slab rows for space. So if we can't check the type of it, but we can check the IFC entity type. So equals IFC entity type is IFC slab. Like this. You could have used actually maybe it makes more sense to pass the IFC entity type here. So let's make it a little bit nicer. IFC type. Let's use this code from here instead of passing the class. If it matches the type we give it, that way we should be able to use it for slab as well. So here we IFC entity type and IFC door and window and wall. And the last for the slab. So we have all the 4 cases. And let's remove this as unnecessary. Now we have it kind of nicely. And let's also remove this special door handling. And we can try to run it again and see if we are close to the info viewer that we saw. And let's take the space that we had earlier, the 0.4, as the example one. Doesn't work, so I guess we have a bug here. Let's see. 158. Not all components have an entity type, so here we assumed that the entity type exists. So let's add another if case here, like this, if that is present and if it matches the IFC type we wanted. And let's have another go at it. Now we get something, so it doesn't crash at least. Space boundaries. We get 1 row for door, and the amount is the same. We get 1 row for slab, and 2 rows for windows. The wall doesn't seem to be working, so we have no rows for wall. Let's check why is that. So from let's check what kind of walls we have in the model. So are they IFC walls or are they something else? Because walls can be also yeah. So we have IFC wall standard case. So let's add that to the list. So this is nice because it adds the same kind of rows for both of these IFC cases. And let's check if they're all wall standard case. They seem to be. So this should fix that final flaw in this example. The IFC type, of course, depends on how the things are modeled, so from how it's been exported from the modeling software. And let's check it. Oh, did I break it again? No, I chose the wall. I should have chosen the space. Yeah. So now we have 4 rows for wall, and one of them is is 0.0. Okay, they seem to match as well what we had there, so we're quite close to what we have in the info viewer. We could still add this space boundary row. Maybe I'll skip it here, it's quite simple to add. So if somebody after this session wants to take this example and add it, it should be doable by looking at the code a little bit. You just take all the space boundaries and get the area from them. One thing we could look at still is do we want this table to be like dynamic? Now, what are these walls? This table doesn't tell you which walls these are. We could possibly make it allow you to zoom into them. And for that we do have some APIs available. So let's check the documentation again. In the 3D, it's not there, it's part of T, and we have camera. So the API allows you to look at components, so calling this makes the 3D zoom into the chosen components. And let's try adding the call to it, so get 3D, get camera, and look at. So we can give it a list of components. And it's possible for us to add a listener to this table. Same way we added a listener to the button, so we can execute actions. From the table, we can add it here. Let's try adding a JTable mouse click event listener. So something simple like this. Let's put it to the bottom where we do the button as well. So what the listener does is whenever you click it, it gives you this event. From the event we can get the row and column from the table that the mouse is on. Let's also make it so that if you double click, you execute something, so we can make it have a click count. And zoom into components. And let's see if this works. Let's pass the row and column to it. Let's put it here. Now here we could call this when we figure out the component from the cell. So what would we want to zoom into? We could maybe zoom into the space, or we could zoom into the components that are next to the space, so maybe to the door or the window. And let's keep it simple. So let's just use the row. Here, let's not do anything with the column. Whenever we do the update data, let's also create a map. Map from row number to list of components. And we can use this map then in the method to, from the row number, find out the components. So row to components map. And this is simple. We just get it with the row number, and we do need to fill it. So when we are adding rows, here we are dealing with the space boundaries of the row. So while at it, let's also add all the related related building elements to the map. So let's here first get how many rows exist in the table yet. So let's get the size of this. Size will tell you how many rows there are. So let's take one out from it because it starts indexing from 0. Let's put an empty list there. So let's clear the data first. And then for all of these, let's not get the list, but let's just reuse it here so we avoid some calls to the map. Component list like this. Let's put that list here and then add some components there. Let's see. Yeah, we do want to iterate all of these, so let's also loop them. And from each space boundary, let's get the related building element. Let's just in case put a if statement here. If it doesn't have, it should have, but we can check if it doesn't. So now we should be populating this list. We should be putting it into this map, and whenever we double click on a row, we should be zooming into those into 3D. Let's see if it does what we want it to do. Let's add our favorite space back to the selection basket. And let's see if our double clicking works. So it could be broken, or it could be that because the table allows you to modify the cells, it doesn't register the events. So let's make it so that the cells cannot be edited. So let's make the table uneditable. Let's disable editing there. Is cell editable? And we are creating the table here. Complicates this a little bit. Let's see if we can make it editable later. Let's try disabling. I don't know if it responds to our events still, but this should be one way to make it not editable at least. Maybe it responds to our event, maybe not. Let's see. It's not an editing event, so we will see. Okay, so it does prevent the editing, but it blocks the blocks the event apparently as well. So we need a different solution to it. Yeah. So we can't use that. Here, let's say if we have a nice constructor for this that allows us to give all of those inputs that we want. So we want to give it this table model, and the table model would be would not allow editing any of the cells, but it could still have listeners for it, and we need to define the row count and column count here. Well, we can use the default implementation, the abstract implementation. Let's see if we can get that done still in this session. Cells are not editable. Does it want us to? And let's add the necessary methods for it, and let's give it a constructor. So we will now put this data vector inside the model, so it will have the same data here. Well, it doesn't really need it here because it can just ask from the public. So let's keep it simple. From the data, can't be static. Then it will ask from the view about the data. So it can just call the size, and then the column count is always 4, and getting the value at given row and given column. So you get with row and then with column index. And we should be able to put it as a parameter here. Another thing here is that we lost the column names. So let's see how to get those back. And if we can initialize them, and it does have this nice method we can implement here. It has column count and then column names. And we can get it from the column vector with the index. So this might now work for us. Let's see. And using these custom table models allows a lot of customization. So only in the most basic case we would be using strings here, like directly. But it's a good starting point. Okay, now actually the zooming worked, so it zoomed into something, or at least it works for some row here. Let's check. It's the same space, so we did get it working for at least this. Let's see if we get some error logs here. No. Okay, so we did get the zoom working, at least partly. So now if we wanted to kind of check why it's broken, we might have an index error here. This might be one too small or one too big or something, and that's why it's getting an empty list or something. We can add debug statements here, or similarly debug it what data we have there, and we can debug what kind of data we are inputting and into what index we're putting it into. But I think I will now leave this like this. So I think this is a good starting point. Let's recap a little bit what we did. So we did have a export to Excel functionality. So taking some data from Solibri and writing it into an Excel file. We do have a nice little table here that we can present, and we do have events that can happen when you click on it. So we can have make the view react to mouse clicks, and we can make it react to key presses and whatever we want. And before that we defined the custom information for walls. So it is here, I hope. Well, anyway, I think that's good enough for this session. We've had a quite a nice long session, so I will be posting all of these examples in a cleanup form into the GitHub examples at some point when I have the time to polish them nicely. And if there's any questions still, I can still answer them, but otherwise I think the coding part is finished here. So let's see if we can get some YouTube questions, and if not, let's finish the stream. Thanks to all of you for joining, and we might of course have these in the future if there's more interest in this, and if you guys come up with more examples you'd like to see. Yeah, thanks everybody. There doesn't seem to be any specific questions, but you can always ask any questions in the society forum. So thank you all.